Hi, this is Shannon Seaver. Today we are looking at rational numbers part 2. Specifically, we are looking at how to perform operations with square roots, adding and subtracting mostly, and then we're also looking at rationalizing the denominator. When we're adding or subtracting a square root, notice that the square roots have to be the same in order to add them. So notice that this is a square root of c. And because of that, we can then add a and b together and put that in front of the c. So as long as they're the same, they can be added or subtracted. So let's look at our first example. Notice that the square root of 2 is the same. So I can rewrite this as 7 plus 5 square root of 2, which happens to be 12 square root of 2. Same with this one. We have the square root of 5 here. So I can say 2 minus 6 square root of 5. So this would be a negative 4 square root of 5. On this one, notice that there is one that is not part of the square root of 7. The other two are square roots of 7. I can add those two together, but I cannot add the square root of 3 to it because they're different. So I'm going to take 3, and you can assume, because there's nothing in front of this, you can assume that's a 1. So 3 minus 1 square root of 7 plus 9 square root of 3. So this would be 2 square root of 7 plus 9 square root of 3. Now there's also times where they're not completely simplified, and sometimes when you simplify them, you find that they have the same square root. So let's look at this one, for instance, 8. Notice that if I broke this down into its prime divisors, we have 2, 2, and 2. Okay? So this is the same thing as saying square root of 2 plus the square root of 2 to the third. Since we have at least two twos, we have 3 actually, but we have at least 2, we can rewrite that as the square root of 2 plus the square root of 2 squared plus 2. And now this can be brought outside of the square root bracket. So now we have square root of 2 plus 2 square roots of 2. They are the same, so now I can add them together. So this is like saying 1 square root of 2 and 2 square roots of 2, so I have 3 total square roots of 2. We can do the same thing with this one. Let's break down 50 into its prime factorization. So I have 5 and 10 and 2 and 5. So I can rewrite this one as 4 square root of 2 times 5 squared. And let's do the same thing for 32. We have 4 and 8, 2 and 2, and then 2 and 4, and 2 and 2. So this is minus 6 square root of 2 to the 5th. Now I'm going to write this as 6 square root of 2 to the to the second times 2 to the second times 2, because I can take these ones that have to the power of 2 out, okay, and this can be taken out as well. So I have 4 square root of 2 times 5 the second. So now let's bring those outside. So I can say 4 times 5 square root of 2 minus 6 times 2 times 2 square root of 2. So this will become 20 square root of 2 minus 24 square root of 2. And if I actually put those two together now, because they are the same square roots, I'll have negative 4 square root of 2. So now I want you to pause the video and try this on your own and come back and check your work. On the first one, you should have gotten 3 square root of 3, and on the second, you should have gotten negative 13 square root of 2. Hopefully this is what you got. Now let's talk about rationalizing the denominator. In math, we never like to see a square root in the bottom part of the fraction, the denominator. So what we have to do is get rid of it somehow, and the best way to do that is to multiply both top and bottom by that square root. What happens when you do that is that the square root of 6 times the square root of 6 just becomes a 6. And then I have 15 square roots of 6 on the top. Now, if I could, I should reduce this. And notice that 3 goes both into 15 and 6. So I can divide top and bottom by 3. So I have 5 square root of 6. And then I have 2 on the bottom. So this is my rationalized denominator. On this one, I can change this to the square root of 3 over the square root of 5. We learned that in the last lesson. I need to get rid of the square root of 5 on the bottom, so I'm going to square times it by the square root of 5. And now I have 5 on the bottom. And then remember, when you have a square root times a square root, it's the same thing as saying 3 times 5 inside the 1 square root, which means it's the square root of 15 over 5. 15 can't be reduced anymore, so this is as far as I can take it for that one. I'm going to do the same thing for the last one here. I'm going to take square root of 8 times both of these. So now I have 12 square roots of 8 over 8. I can also reduce the square root of 8, so I'm going to do that before I go any further. I know that it's 2 to the third is how many goes into 8, so I'm going to say 2 to the second times 2. And now this 2 can be taken outside the radical. So it'll be 12 times 2, square root of 2, over 8. So this is 24 square root of 2 over 8. And 8 goes into 24, so we're fortunate that way. We can just rewrite this as 3 square roots of 2. So now, I want you to take some time to try it on your own and come back and check. This is the end of the lesson, so when you check, that will be the end of the video. On the first one, you should have gotten 5 square root of 10 over 2, and then square root of 14 over 7, and lastly, 5 square root of 2 over 6. Hopefully this is what you got. If you have any questions, please bring them to class.